Hello, and thank you for joining. We're going to go live in a few seconds. I'm just waiting for a few more people to join us. Okay. Welcome. Welcome to our first online lesson on probability. And today we'll be doing some work on probability with two-way tables. You're going to need a pen, a piece of paper, and a calculator. There was a worksheet or a handout available. If you've got that, great. If you haven't, you can still use this lesson, but you might need to watch it back. Okay, let's get started. So just bear with me for 1 second. All right. So we're going to calculate the probability from two-way tables, and we need to remember how to calculate a probability to begin with. So the probability of an event is found by the number of desired outcomes by the total number of outcomes. This is a bit more difficult with two-way tables because it's not always clear it's not always clear how many desired outcomes there are or the total number of outcomes. So we'll take it step by step. I'll go through this question and then I'll give you a question to do in a minute or two. So a person is chosen at random. We're going to calculate the probability of that person being a girl. So in our total sample, our total number of outcomes, we've got all of these frequencies. So we're going to add them together, and we've got 8 and 12, which is 20, 23, and 30. So the probability of choosing a girl is going to be out of 30. And there are 20 girls, 8 that do walk to school and 12 that don't. So in total, that is 20. But we're going to simplify this fraction by dividing both by 10. So that will cancel and that will cancel, and we're left with 2/3. The probability that a person walks to school. So probability of somebody walking, well, our total number of outcomes is the same, that is 30, and the number of people who walk, well, you can have 3 boys that walk and 8 girls that walk, so that is 11 desired outcomes. Now we get a bit more interesting, a bit more difficult, because the sample or the total number of outcomes has changed because of the people who walk. So now we're not looking at everybody, we're only looking at these people. So probability that a boy is chosen, but only considering the people who walk. So now there's 11 people who walk, so our total outcomes is 11. And there are 3 boys who walk. So that probability is 3/11ths. And the last one, the probability of the boys available, and let me just rub this out. So in total, there are 3 and 7 boys, so there are a total of 10 boys, and we want the probability of not walking. Which is 7 boys who do not walk out of 10. Okay. If I'm going too fast or too slow, leave a comment in the comment section and I'll adjust my pace accordingly. So why don't you have a try at this question here. If you've got any questions, try and leave a comment and I'll go through it with you. Welcome to Hamid, Owen, Ahmed Wizard. I can see you're back again. Spaghetti, I appreciate the thumbs up. Okay, let's just make sure we know the total number of desired outcomes. So the probability of an event is the desired outcomes divided by the total outcomes, and the probability of a person being chosen as a girl. Well, there are 9 girls, but the total sample, I'll leave that with you for a couple of seconds. Well, we have far more people joining us today than yesterday, so I'm really pleased about that. Thank you for watching. You're very welcome. I hope you do find it useful. We have Surge Dragon, Armored Wizard, Isabel, hello, Owen, hello, Spaghetti, not sure who you are, but welcome. Okay, so the total number of outcomes, well, there are the 7 over 5 is 12, 15, 20, 24 outcomes. So that is 24 possible outcomes. That is 9 out of 24. And we can simplify this fraction by dividing both by 3. So 9 divided by 3 is 3, and 24 divided by 3 is 8. So the probability of picking a girl at random from this sample is 3/8. The probability of picking somebody with blue eyes, and the probability of picking a boy with green eyes. I'll leave that with you for a minute or two, and then we'll go through it. Feel free to continue working through the questions if you're finding this quite doable. We have another person joining us, that's 25. Really pleased about that. You're all very welcome. I hope you're finding this useful. Okay, so 20 more seconds and I'm going to go through the next 2 questions. This one and this one. Like I said a minute ago, do try this one if you can. It is a little bit more challenging. I'll let you think about why that is. Okay, so the probability of picking a student that has blue eyes. Well, we know there are a total of 24 students. And the students who have blue, well, 7 boys and 5 girls do, so that would be 12. And we can simplify this fraction by dividing both by 12, and we have 1/2. So there's an even chance of picking a student with blue eyes. And now we can really narrow this down, because we're not looking at a boy anymore, but now if a boy has to have green eyes, so we're being much more focused. And there's still a sample size of 24, and the boys with blue eyes are highlighted here. So that is, boys with green eyes. So this is going to be 5 out of 20. Oh dear. This is going to be 3 out of 24, which is going to be 1/8. Okay, question C. A girl is chosen at random. Now, this makes it more challenging because we are changing the total number of outcomes possible. The total number of outcomes now is the total number of girls, because it is a girl that is chosen. So there is a total of 9. So the probability of not brown, I've now had a total sample of 9. A girl is chosen. Find the probability she does not have brown eyes. Well, 3 of them do, which means 6 of them wouldn't. So that is going to be 6 ninths. And we can simplify this fraction by dividing both by 3. So we get 2 thirds. Okay, let's make it a bit more challenging, shall we? So, 100 students visited a youth club over 3 days. The two-way table shows the information about these students. Try and complete the two-way table. I'll give you a bit of a prompt. We can work out this value using these two. We can work out this value using these two. And we can work out this value using these 3. Whichever way you want to start doing that is totally up to you. I'll give you 30 seconds or so, and then we'll go through a little bit of it together. I appreciate that, Ahmed Wizard. If you're confused on a particular question, let me know which one and I will go through it with you. And you can always watch a video afterwards. That will help. Okay, so I'm going to begin just by choice. I'm going to work out this value first. If the total is 100 and there are 43 boys, that will be 100 minus the 43 to make 57. So in total there are 57 girls. And we can work out this value by doing 100 minus the 34 minus the 30, and that comes out as 36. And this one we can work out doing 30 take away the 16. And that works out as 14. So I'll give you a couple more minutes to finish it off, and then we'll go through the probability questions together. Oh, it's Ahmed Wizard is done. For question 2, why is it 6 and not 4 over 9? Give me 1 second, I'll look back at that and get back to you. So, going back to the previous question, why is it 6 and not 4 over 9? Because there are a total of 9 girls, and 5 of them have blue eyes, 1 of them have green eyes, but we wanted the number of brown eyes, so that would be the 9 take away the 6. So the 9 take away the 3, which would be 6. Okay, let's go through the rest of this two-way table. Well, we can work out this value by doing the 57, the total, take away the 14, take away the 21. And that's going to come out as 22. We can now work out boys on Wednesday by doing 34, the total, take away the 22 girls, and that comes out as 12. And the boys on Monday, we can do using the total number on Monday, which is 36, take away the 21 girls, and that's going to be 15. Now, I just want to make sure I've calculated this correctly. So I'm going to do 15 add 12 add 16, and that should make 43, which it does. Brilliant. Okay, so let's move on with the probability questions. Well, one of these students is chosen at random. This is question B. Write down the probability that the student is a girl who visited on Wednesday. Well, we know there's a total of 100. So out of 100 total outcomes, we want the number who is a girl that visited on Wednesday. And this is here, 22. So 22 over 100, and that comes out as 11 over 50. Question C. A boy is chosen at random. So now we're only looking at the number of boys. So our total possible outcomes is now given to you as 43. So out of 43 possible boys, we want the probability that the boy did not visit on a Friday. So did not. So that could be Monday, or it could be Wednesday. And that comes out as 27, 15 add 12, 27 over 43. Okay, let's give you a question to try and do. I'll read it for you, and then I'll give you a couple of minutes, and if you've got any questions, write them in the chat, and I'll try and go through it with you. So there are 80 students choosing to study humanities. They are history, or religious studies, or geography. The two-way table shows some information about the choices. We've been asked to complete the two-way table. So a bit like you did a minute ago, I'll wait a minute before I give you any clues. And if you've got any questions, please leave a message. So, Devil Winner, can you make them harder? Not gonna lie, this is easy. They will get more challenging. It is difficult when I'm trying to cater for a lot of people. But if you stay with me in future lessons, you will see the lessons do get more challenging. And the next question in particular is quite interesting. Maybe if you do find it easy, you could respond to some questions from me if people find it difficult. I appreciate the feedback. So I've been told to do some shout outs whilst you're doing this question. 20 seconds and we're going to go through it. So apparently Devil Winner's dad gave up. Devil Winner, you just mentioned you found it easy. Can you not teach your dad? Okay, I'm just going to go through a little bit of this question now. So, first thing I'm going to do is I'm going to work out the religious studies. I can do this because the total is 44. And I'm going to take away the 16, which is geography, take away the 18, which is history, and that will leave me with people who studied RS, and that comes out as 10. From here, I could work out the total religious studies, I could work out the males who chose geography, and I could work out the history by doing the total, take away the female. I'll give you another 30 seconds and then I'll finish off. Then I'll go through this question. Oh dear, we've had a milk spillage. I hope that cleans up easily for you. I'm not quite sure what sonic writing is. Okay, let's go through this question, shall we? So the total number of religious studies is going to be 10 at 19, which is 29. And the number of geography male students will be 23, take away the 16, and that's going to be 7. And then the male history is going to be 28, take away the 18, which is 10. So one of these students is picked at random. We're going to write down the probability that the student is a female who chooses RE. Well, there's a total number of 80 outcomes, and we want a student who's a female and chooses RE. So female and religious studies, which is 10. And we can simplify this fraction, dividing both by 10, and we get 1/8. One of the male guests is picked at random. So now we're looking at the total male. So out of 36, what is the probability that this male chooses history? And that will be 10, because there are 10 history here. And we can simplify that fraction to make 5/18. Okay, so the last question of the lesson. I'm going to give you a couple of minutes to complete the two-way table from the written description and then try to answer this question. So I shout out to Alfie, it's good to have you doing this lesson. And Ben, I hope you're working hard, Ben. Ahmed Wizard, let me know when you've managed to complete the two-way table. Thank you for the feedback, Lily. It looks like Lex is enjoying herself. So in about 20 seconds, I'm going to give you some more prompts for the two-way table. Well done, Kai. Max, I hope you're working hard. That's an interesting point, Devil Winner. Maybe we should ask him later. Okay, let's have a look at this question then. So we have 22 people want to study English. So that's a total of 22 here. 21 people want to study engineering. So that's and 5 people want to study mathematics and computer studies. So mathematics and computer studies, the 5 goes there. Okay. I'll give you another 30 seconds or so to try and complete the rest. Thank you, Joel. Well done, Ben. Appreciate the smiley face. Okay, 20 more seconds and we're going to finish this question off. If I am going too quick, or if you want more time to complete the question, just send me a message and I'll slow down. Thank you, Shannon. So we're going to be finished for lesson in about 5 minutes. Okay, let's go through this, shall we? So we know 40 people were chosen in total. 21 of them chose engineering. So 19 of them would have chosen computer studies. And if there's a total number of 19 that chose computer studies and 5 of them chose maths, then 14 of them must have chosen English. And actually, we don't need to do any more questions or more of these because we're only being asked about English and computers. But I will, just to help you. So 13 and 8, and that will be 18. We know it works because we can add all of these up and they do make the totals. So English and computer studies would be 14 out of 40. And I hope you all simplify this fraction by dividing both by 2 to get 7 over 20. Okay? So I hope you found that useful. Thank you very much for tuning in. There will be another lesson tomorrow where we will do some more work on probability. I hope you're keeping safe and take care.